Now we're going to start by the integral. Since derivative of ex is ex, so integral of ex is ex. And by chain rule, integral of eu, if you have expression, you pick this to be u, is eu. Let us do this integral. Integral of 2x, you all know 2x squared over 2. Integral of ex is ex. So minus 2ex plus 3x plus c. Here we have, if the form e power u, let u equal 3x. So du equal 3 dx, so it will be 5, this is u, and dx is du over 3, so it's 5 over 3 integral of eu du, which is 5 over 3 eu, and u is 3x. But from now and on, if you have, for example, here 3x, no need to do the chain rule. Directly, derivative of 3x is 3, so we write 5e3x and we divide by 3. For example, here, e power 2x minus 1, derivative of 2x minus 1 is 2, so the answer will be minus 3 e power 2x minus 1 divided by 2. Here the derivative is minus 1, it will be minus 3 e minus power minus x divided by minus 1, which is 3e minus x. Here it will be 7e 3x minus 1 over 3, and this one 2e power minus x plus 3, because the derivative of minus x plus 3 is minus 1, and if you divide minus 1 by minus 2 by minus 1, it will be 2, instead of doing the chain rule, because these are very direct and simple. Here we need to do by part, let u equal, not by part, sorry, by let u equal 2x squared minus 1, so derivative is 4x dx. So here you're going to have integral 3x e power u, sorry, 3x e power u, and dx is du over 4x. X and x cancel out, so you have 3 over 4 eu du, which is 3 over 4 eu, and u is 2x squared minus 1 plus c. Here it looks like logarithm. Why? Because I have denominator and power is 1, so let u equal to ex minus 3, du is 2 ex dx, so this is u and this is ex, and dx here is du over 2ex, ex cancel out, so have integral du over u, so half ln u, and this is u in absolute value. Here, if you want to do this one, let us see here, if you pick u to be e2x up, you cannot cancel down, so let me pick u to be ex, for example. U is ex, so du equal ex dx. Now we have e2x plus 1 over ex dx. Since u is ex, so e2x, it means you have u squared plus 1 over u, and dx is du over u. So now you can see u times u is u squared. So now u squared, you can split it, u squared over u squared is 1 plus u minus 2, so this will be integral of 1 is u because it's in du, and integral of u minus 2 is u minus 1 over minus 1, which is minus 1 over u, where u is ex. Here we need to do it by part. Why? Because derivative here I have x ex, and we cannot cancel this x, and if you pick e to be ex, you cannot cancel x. So let u equal x, so derivative of du is dx, let dv equal ex, integral of ex is ex, so it will be uv, it's ex minus integral v du, v times du, and integral of ex. You know that integral of ex. But from now and on we can use the table. When we can use the tabular form? Tabular form, if you have one of them is exponential, like you can see here, and you have a polynomial, so you take the polynomial, you put it apart, and you take the exponential on the other side. You start deriving the x, so derivative of x is 1, derivative of 1 is 0. We can use table always when you have the derivative of, for example, polynomial where the derivative ends at 0. If the derivative does not end, for example, if you have sine, you cannot take it as derivative because it will not end. So we need polynomial where derivative it ends. And here we do integral. Integral of ex is ex, integral of ex is ex. So we put these arrows, we start by plus, minus, etc. Here I have only 2, plus, minus, so the integral will be directly x ex, as you can see the product here, minus ex plus c. So let us take more example to understand. Here I have a polynomial, as you can see. Instead of doing it by part, we can do by part, you can follow here. let u equal 3x minus 1 du 3x, let dv equal e2x, so v it will be e2x over 2, so it will be uv e2x over 2, you can see it here, e2x over 2 times u, okay, minus integral v du, it will be etx over 2 times 3, which is 3 over 2 e2x, and integral of e2x, it will be e2x over 2, and you have 2 over 4. So this is by part, but now we're not going to do it by part here. So we put 3x minus 1, this is a polynomial where the derivative ends. Derivative of 3x minus 1 is a 3, derivative of 3 is 0. Integral of e2x is e2x over 2. Integral of e2x over 2, it will be e2x over 4. So plus, minus. So it will be 3x minus 1 into half e2x minus 3 over 4 e2x, the same thing that we got here. If you want to do this derivative, this integral, so you take 2x squared minus 1, 4x, derivative 4, derivative 0. We can use it, why? Because we have polynomial with the exponential. Integral e minus x is e minus x over minus 1, and integral of minus e minus x, so it is minus e minus x over minus 1, so e minus x and minus e minus x, you put plus minus plus, so it will be 2x squared minus 1 into minus ex minus x, as you can see, minus e minus x 4x and minus 4e minus x, and of course here we need to continue, so you put e minus x in factor, so what do we get inside? We get minus 2x squared plus 1 minus 4x minus 4, okay, and certainly 1 minus 4 is minus 3. Now, if you have here, I have ex minus sine x. Please be careful about ex sine x and ex cosine x for some integral. So here we cannot do table form. Why? Because neither the sine nor the ex derivative ends, so we need to do it by part. Let u equal sine x, du is cosine x. Always we take by part dv to be ex, so v equal ex. So it's uv, so ex sine x minus v du, so cosine x ex. Here we need to do also by part another time. Let u equal cosine x, du is minus sine x, let dv ex, v is ex. So if you do it, integral of ex sine x dx, so it's ex sine x minus, this is uv, ex cosine x, and you have minus before, and minus plus integral u dv minus ex sine x. Now I'm not going to do by part anymore, because here I have ex sine x, here I have ex sine x, and you have the minus before, so I take it to the other side. This minus before will be plus, so you're going to have 2 integral ex sine x dx equal ex into sine x here minus cosine x, and what will be integral of ex sine x? It will be ex over 2 sine x minus cosine x. And if you have ex cosine x, let u equal cosine x, du is minus sine, and if dv equal ex, so v is ex, integral of ex is ex, so by part it will be uv minus and minus plus, you have sine x ex. Here again I do it integral by part, u is sine x, derivative cosine x, and dv ex, v is ex, so this will be ex cosine x plus uv ex sine x minus v du cosine x ex, okay. So here sorry, here I have cosine x because I did it by mistake, cosine x. Now since I have ex cosine x here and ex cosine x and minus, I take it to the other side, it will be 2 ex cosine x equal ex into cosine x plus sine x, and what will be the integral of e cosine x? It will be ex over 2 cosine x plus sine x. Thank you for listening. The third one is going to be about graphing some exponential function. Thank you.